For his amazing commitment to the fields of material science, Michio Kaku has, in reality, declared that the James Webb Space Telescope has seen 6 enormous structures that experts thought couldn't exist. These evaluations have the possibility to open up new points of view in how we might interpret the universe. The disclosure is both enabling and moderately challenging existing speculation about the improvement and headway of universes. It is consequently worth watching out for these updates. The affirmation by such a recognized expert highlights the significance of these exposures. Michio Kaku is a striking figure in the scientific field, a physicist of American and Japanese heritage. He is seen as an expert in both conventional experimental material science and quantum mechanics. Unlike some more conservative and controversial experts, Kaku has been open to the unimaginable ramifications of the James Webb Space Telescope mission. His eagerness to embrace new discoveries and share them with the public emphasizes his commitment to advancing our understanding of the universe. We are pleased that this recognized expert has chosen to end his silence and openly share what can no longer be denied. The excitement and almost animated tone of the renowned physicist are evident in his remarks on the discoveries made by the James Webb Space Telescope, indicating that this has been a highlight that has stirred his curiosity. Join us in exploring the implications of Michio Kaku's disclosures regarding 6 gigantic systems. Kaku is a visionary scientist who has consistently considered new theories throughout his life. He has demonstrated a willingness to entertain ideas that challenge the norm, recognizing that while Einstein's theories of relativity and Newton's laws are fundamental, they fall short of fully capturing the complexities of the universe. Kaku understands that the discoveries of the new telescope have the potential to not only advance the intellectual field but also reshape our understanding. However, many of his colleagues have not embraced this view, which has caused concern and unease among proponents of the Big Bang theory and adversaries of quantum mechanics. Nevertheless, this only elicits laughter from Kaku. The JWST has uncovered the existence of 6 massive galaxies dating back to the earliest times of the universe. Each of these enormous structures contains more stars than our own Milky Way, despite having formed only 200 to 700 million years after the Big Bang. The team of space experts who made the discovery has named these spectacular galaxies universe breakers, because if confirmed, they would change our entire understanding of the universe. The implications of these discoveries are vast, suggesting that the early years of the universe were far more dynamic and complex than previously thought. Something doesn't fit here anymore. The theory of how things came to be tells us that the universe was a chaotic mass after the initial event, and the first solid objects took countless years to form. It took even more years for these objects to reach sufficient density to produce light. The formation of complex structures such as galaxies was believed to occur much later. Some of the newly discovered galaxies dwarf the Milky Way in size, and their immense brightness suggests that they were likely forming many new stars each year, while our system forms stars only sporadically. It remains unclear precisely when the first galaxies formed. Researchers have not yet been able to determine this. The only thing that is clear so far is that initially, there may have been just single stars or clusters of stars, which eventually coalesced to form progressively larger structures until dwarf galaxies developed. The small cosmic systems encountered various structures and evolved over time, contradicting previous theories that organized and massive galaxies couldn't have existed at that time. This raises the question of whether the universe is much older than recently recognized, or whether complex cosmic designs developed much sooner. This situation is difficult for standard science to accept, as it still struggles with this model. Some aspects of physics strongly refuse to accept this discovery and question possible errors in the age estimates. Kaku is aware of this and had this to say: there are various models of ancient and misleading theories that persistently survive due to the influence of certain experts. Many of these theories were perhaps disproven when major experiments revealed their flaws. Thus, the first word in any science, particularly in physics, rests with the experimentalists who keep scientists alert and mindful where truly on Earth we have little insight into the true origins of the universe. This statement from Kaku emphasizes the importance of consistent experimentation and validation in the scientific process. The theory of how things came to be was laid out in 1927, based on observations of the universe's expansion. This data led to the conclusion that the universe began from a single point and has been expanding ever since. At the time, it was hard for people and scientists to imagine a universe with a beginning and an end. The idea of a universe that had always existed and was infinite was beyond people's imagination. Without a doubt, even today, scientists still face challenges in figuring it out. However, it is essential to consider these possibilities. Even these new discoveries do not align with what scientists have been asserting for a long time regarding the Big Bang theory. Still, Science has consistently shown that re-evaluation and openness to revolutionary ideas are critical parts of the scientific process. Much like the affirmation of specific theories and observations, when Einstein was a young man, it was widely believed that the stars and planets were solidly fixed in the universe and that these specific arrangements occupied defined spaces. However, we now know that everything in the universe is moving. Planets orbit stars, stars move within their galaxies at various kilometers per second, and entire galaxies move rapidly through the universe, whose fate we cannot yet predict. This new understanding of the universe challenges long-held beliefs and highlights the need for continuous inquiry and change in scientific thought. Today, scientists are challenged to accept uncomfortable pieces of understanding and to grasp that theories are not absolute truths until they are thoroughly tested or confirmed by empirical observation. The possibility of the Big Bang emerged from the recognition that galaxies are moving away from each other, and this distance is proportional to their separation from Earth. This observation, known as Hubble's law, suggested that the universe was expanding. For some time, elements such as cosmic background radiation, the red shift of light from distant galaxies, and other cosmological patterns appeared to support this theory. However, it is essential to remember that previously, people who believed the Earth was flat and that the Sun revolved around us also had observational evidence for their doubts until events or technological advancement provided a clearer picture. Right now, we are witnessing a similar situation. Scientists expected the new James Webb Space Telescope to confirm the assumptions related to the Big Bang. However, instead, they have encountered these 6 galaxies that seemed impossible. This shows that science is continuously evolving, and experts must remain open to new discoveries and re-evaluate existing theories based on the available evidence. The unexpected discoveries challenge our understanding and prompt a reassessment of long-held cosmological theories. Experts use redshift as a tool to determine quantities in the study of the universe. Redshift, also known as the Doppler effect, refers to the change in the color of light as light sources and observers move relative to each other. To understand this, you can imagine standing still and seeing a car coming toward you. As the car moves toward you, you hear the engine getting louder. However, when the car passes you or moves away, the engine sound changes. This is because the sound varies as the car moves. The same is true for light. When a light source, such as a distant star, moves toward us, the light we see shifts toward bluer tones. On the other hand, when the light source moves away from us, the light shifts toward redder tones. This phenomenon is called redshift. Physicists have converted redshift values into speeds and distances for measurement in the study of the universe. However, it is important to note that even a small error in these measurements can have significant consequences. The measurement techniques recently used are now under review. The latest discoveries related to our universe require consideration of whether they are truly based on redshift errors, or whether some scientists are simply denying the facts. This is a question that requires thorough investigation and careful review of the data and methods used in the analysis. The current examination and reassessment of measurement techniques highlight the evolving nature of scientific inquiry. Thank you for watching the video. As always, we remind you that you can post your questions in the comments box. If you enjoyed the video, be sure to hit the like button, share it so it reaches more people, and subscribe to the channel so you don't miss more content like this. Thank you for watching and see you in the next one. This call to action encourages viewers to engage with the content, fostering a community of curious minds eager to explore.